So the next talk is actually a discussion and will be carried out by Brian Goetz and Nicolai Parlog. Nicolai is with the Oracle Java developer and advocate. And I would like to invite then Nicolai and Brian to the stage. Hi, welcome.
Hi.
How do you do?
Very good.
We're doing fine, thank you.
Great. So stage is yours. I will stay here with you and moderate if there's any question and stuff like that. Feel free to also ask if you have questions to me.
Sure.
Thank you.
Yeah, so this is an Ask Me Anything. Well, not me. It's an Ask Brian Anything session. All right, the guy in the nice hotel room. So Brian is you're Java language architect. Is that that's the correct title, right? I'm not good on titles.
Yeah, that's right. Java language architect.
All right. So Brian knows a thing or two, not about how Java works, but also why it works the way it does and how it might work different in the future. And so this is your chance to ask some questions. So if you're on the ping stage right now, that's perfect. Just put them into Hopin, and I'll see him there, and I'll forward them to Brian. And until we get a few questions from you, I'm just going to ask one of my own. Because I have a superficial level distaste for null that I try, so to the point that I try to avoid it altogether, at least as a legal representation of anything. And I always felt I was a bit alone in that. But I now feel like Brian, you got my back now. I heard you mentioned recently that you got a newfound, I don't want to put words in your mouth. Did you say hate or distaste or whatever, a newfound aversion to null? So I want to ask what's up with that? What's that about?
Yeah, so you know, this is be careful what you say on Twitter time, right? So you know, I was at one point a few weeks ago, you know, I made this cryptic Twitter post of I hate nulls, and of course, you know, I got a gazillion likes for that, you know, and people went to my SoundCloud and so, but you know, and a lot of people asked why, and I didn't, you know, there wasn't room on Twitter to, you know, explain, but I think a lot of people would have guessed wrong, right? So most developers hate null because null pointer exceptions. And that if you're not sure if something is null, you have to check for null, it clutters up your code, and all those if null checks is like more code than the actual, you know, business logic of what you're trying to do. And of course, you know, people helpfully say, well, why don't we have the Elvis operator to, you know, make that easier? And, you know, my opinion on that one is, well, that's just moving the problem somewhere else. But I understand the pain that people are in because of that. And some other languages have experimented with type systems that include nullity. So both C# and Kotlin have what we call the emotional types, you know, the T question mark and T exclamation, you know, that feel either strongly or you know, are doubtful about their type. And those seem nice at first, you know, and I'm a big fan of type systems. So you know, I think if we can represent things in the type system, that's a good thing. But again, I'm not sure that's the solution people are looking for. But the reason that I was whining about null is from my perspective as a language designer, which is to say that if I look at all of the language features that we've done, lambdas, streams, pattern matching, Valhalla, what I keep noticing is we spend so much time dealing with the corner cases around null. And it's not time very well spent, right? That if you spend, you know, 15 or 20% of the feature on the corner that like no one wants to be in, then that just somehow feels like I could be using that time to, you know, build something that people really want to use, right? And so as a language designer, it is a perennial distraction because it never works the way you want it to work. And like, you know, as an example of that, I mean, you know, so we're adding pattern matching to Java. And, you know, well, we've already added the simplest form of pattern matching, and which is type patterns an instance of. And then in Java 17, we're extending that to type patterns and switch. And then there's more pattern matching coming. We can talk about that more if people ask. But even with something as simple as pattern matching, null intrudes its head. So supposing I switch on some object and I say case integer, case string, case object. And there is a value that's common to all three of those types, and that's null. So should any of those match null? Should all of those match null? I mean, and all the answers are bad. And this is the problem with null, is that, you know, you ask the question and everyone sighs and like, oh, okay, great, this is not going to go well. And then you work out what the possible answers are going to be, and you hate them all. And so if a type pattern matches null, then I say, you know, switch object, case string, integer. It happens to fall into whichever one is first. That's a terrible answer. That's going to be a sharp edge that cuts people all the time. If we say none of them matches null, we kind of have a problem when we get to nested patterns. Because so a nested pattern is saying, let's say I have a record whose component is an object. So let's say that record is called R. I could say case R and then put a pattern inside of that. Does R contain a string? Does R contain an integer? Does R contain an object? And we want the rules at the nested level to be the same as at the top level, because otherwise that's confusing. And if object as a pattern doesn't match null, then there's no way to match the R that contains null. But who are we to tell people, no, you can never use null for any of your, your state again, right? And so you very quickly, you pull on this string and you find yourself in impossible corners where all the answers are terrible and everybody hates you. And if you look at the Amber expert group list over the last like 3 or 4 years, because we've been working on pattern matching for a while, and you'll see like about once a year, I'll post a message of like, okay, here's another swing at how we're going to deal with null and patterns. And, there'll be something about that people don't like. And then we'll have 400 messages of discussion on it. No consensus will be reached. And then I'll go back into my hole, or I'll work on something else or whatever. And we'll repeat the process. And in the end, we come up with the least bad answer that still nobody likes, right? And you wrote that piece about, optional isn't a monad. And why isn't a monad? Because null. And if we made it a monad, then the null behavior would be surprising to Java developers. So you can't win, right? And so this is why I hate null, is because it puts language designers in a position where you spend a lot of time that you could be spending on something else, playing a no-win game and having people hate you for whatever answer you come up with, even if it's the least bad of all the candidates.
Wow, yeah. Although that's not entirely different from the reason why other developers had, specifically what you said in the beginning, right? You spend time dealing with something that you don't actually want to even have, right? So just like say you have a null pointer exception, which is actually already the good case. The bad case is just something doesn't work, and it turns out something was null, some check fell through, or some exception was caught and then not properly processed. So like if we just get like a straightforward null pointer exception, that's already one of the better cases. But yeah, and then you sit there like, okay, I have null here, like where did it come from? And then you have to deal with, once again, with the situation as you described, even as a developer, that I don't want to have. Like, I don't care. That's not the good case. That's not the business value case. That's the hole in the bottom of my program. I have to make sure that not too much logic falls out. Exactly, yeah. Okay, we got a couple of questions. I want to start with Salt. Probably not pronouncing that name correctly. I'm sorry if I didn't. He asked whether there's any chance to have async and await in Java. And so, by the way, he also said that he was on my stream recently the other day. So that was pretty cool. Thank you for being there. I hope you had a good time. Yeah, but the question is, what about async and await in Java?
Yeah, so that is a great question. Because I have this metaphor that I've been looking for a good name for. So I don't have a good name for it, but I'll describe it, and maybe the audience will come up with a good name. But when you're in pain, all you want is for the pain to stop, and and you can't really see very far past the, boy, it would be nice if someone stopped hitting me with that stick, right? And if the pain continues, and you keep getting hit by the stick, you start like bargaining with it, right? Where you say, okay, maybe being hit by the stick isn't so bad, but maybe if you wrapped a nice soft pillow around that stick and hit me with that instead, that would be okay, right? So async await is like wrapping the pillow around the stick. It's taking something that is really painful and making it a little bit less painful. but it really is only kicking the problem down the road. And so async await looks like a very clever solution. But what it does is it subtly bifurcates all of the methods in the ecosystem into two buckets: the ones that are safe to call from synchronous context and the ones that are asynchronous. And one of the things that you realize is that the code doesn't sort of divide itself into those buckets as neatly as you would like it to. So there was a great blog post about this called "What Color Is Your Function?" Mm-hmm. He starts off with this metaphor of, imagine some functions were red and some functions were blue, and you could call red or blue functions from a blue function, but you can only call red functions from a red function. And how would this affect how we code? And obviously, red is async. It's like I said, it's one of these things that it feels like it would get us out of something painful, but it creates a new world of pain. And for example, we saw something like this very similar in the Go community. So in Go, locks are not reentrant. So Java locks are reentrant. If I acquire a lock, and then that same thread acquires that lock again, it says, oh, well, you already have that lock, so no problem. I will increment the lock counter, and then when you release it the first time, I won't really release it because you've already acquired it separately. Then when you release it the second time, I'll really release it, right? So that's how locks work in Java with synchronized, and that's how the library locks, reentrant lock work. And that's great because that means code can compose. You don't have to worry about who's calling me with what lock held or what are they going to do. In Go, locks are non-reentrant mutexes, which means if someone calls you with lock L held and then you acquire lock L, you deadlock. And how the heck are you supposed to know whether you got called? So what happens in the Go, in Go libraries is they write two versions of each function, one, intended to be called with the lock already held, and one of them that acquires the lock and then does something. And, obviously writing the same code twice, two different ways, offers so many opportunities for error. And async await has very much the same characteristic. And so, we have a much better answer, which is, and that's what's coming out of Project Loom. So with Project Loom, we essentially have pushed the async await down into the Java runtime, where for threads that are called virtual threads or lightweight threads or fibers or whatever the official name is going to be, that if they hit a blocking point, they just suspend the task that they're doing, and some other task will run on that, on that. And it means that you can program, the way we always have, without thinking about, is this thing going to block or not, and not thinking about, am I going to run out of threads? And that turns out to be a much more pleasant way to program. And it's what we're used to, and it's what our tools are used to, and it's what our debuggers help us with, and all of that. And so, and async await doesn't even solve all the problems. Async await is nice for things like generators, where you're mostly doing computation, but the way async await works is the compiler takes your code and shreds it into a state machine. And when you call it, it lifts up some object that has the state of the state machine. And when you call it, it picks up the state that, from the previous run. And that works fine for computation-based stuff, but it still doesn't work so well for things that are going to truly block on a lock or an I/O or a network connection or what have you. So Loom sort of addresses the problem, across the spectrum, and it allows you to not have to do all the mental bookkeeping of, is this thing async? Is it going to block, etc. So I think we have a much better solution in the works, and I think the languages that flunked for async await are going to look at what we did with Loom and say, oh, yeah, we should have waited for that.
So the comment about Go, and that's probably too far out of too far into the fields into the weeds that we don't want to go here. But still, it's interesting to why Go made that decision. I probably will we'll ask you about that, or figure it or research that at some other time, because surely they had a reason, I guess. But you already mentioned Loom, which perfectly suits a question by Balázs, who asks, do you have an estimate on the projects Valhalla, Panama, and Loom?
Yes, they're coming.
So, right. I know you can be a bit more precise than that.
So yes, I will try to be a bit more precise, but equally frustrating. So these projects have all made tremendous progress in the last year or two. They've been running for various amounts of time. Valhalla has been running for the longest because it's the biggest and most complicated, and we announced Project Valhalla at Java 1 back when it was still called Java 1, I think in 2014. And it was sort of the big follow-on for Lambda. And a lot of it was inspired by the problems we ran into during doing Lambda. And I was at a panel discussion. I was sitting next to James Gosling, and James turns to me and says, "Okay, this Valhalla stuff is awesome. I wanted to do value types, from the beginning. Really glad to see it coming." But it's kind of like that detective show. The guy always has one more thing to say. But you realize that you've signed yourself up for like 6 PhD theses here, right? And I'm thinking, oh, gee, I'm hoping it's not 6 because that's a lot. But James is a smart guy. He was right. And so maybe we're like 4 or 4.5 PhD theses, through this 6 on Valhalla. So it's taking a long time. But we do actually think we've turned a corner, and we're at the point where we think we're actually driving towards the first deliverable now. So a lot of what we've been doing so far has been experimentation, evaluation, prototyping, exploration. And now we feel like we have a model of we can implement this. And so I think that's really turned a corner. And Panama has actually already delivered big chunks of what it's doing. So the foreign memory API, which will be a replacement for using either unsafe or direct byte buffers to access off-heap memory, already previewed twice, maybe a third time. The foreign linker API that lets you replace JNI for making down calls to native code and up calls back to Java. That I think that is previewing in 17. And so if that's preview in 17, then it's probably final in 19. So that's actually here. And Loom is like the amazing one in terms of how much that's delivered in such a short time, because Loom started after both of those projects, but it has just been moving really fast. And I'm hoping that we're going to see the first preview in sometime like a year plus or minus from now. So we're all of the fundamental problems in Loom are solved. The performance is good, and now we're working on the painting and polishing and what should the API look like and all of that. And those are obviously important and sometimes hard choices too. But those are the things you do last. So we're working on those last things. So I think for these big projects that have been running for many years, and people are kind of wondering, oh, you were never going to see those. You just like to talk about them because they're cool, but they're never going to happen. I think people are going to be quite shocked to see them all land within a year of each other.
Yeah, I think it's important to point out why we're being a bit cagey about this. I mean, in the end, it's like, every software project has it shares certain properties, and one of them is that, predicting the future is hard. So while it does look like all of these projects are, making, as you said, are coming up to the finishing line, and there's a non-zero chance that within a year or two they're all done, but there's also a decent chance, something pops up and it takes longer. Yep. But specifically about Valhalla, I just posted into the chat 2 JEPs, 401 and 402, which were put basically into writing what Brian just said, that there's things coming out soon, that there's progress being made, and that these things will maybe land as previews next year, hopefully, crossing fingers. So Valhalla is, as you said, is on the finishing line. And as you also said, Panama already has these things out. So yeah, they're going to finalize a few things in Sorry, not in 17. Still previews in 17, but maybe then next year.
Okay. And you know, I mean, one of the things you and I, talk about how is there's a lot of people who like are engaged in the wishful thinking of, oh, Java 8 is all I'm ever going to need, right? and so my job is to prove them wrong by like continuing to add cool new things to Java. And between like 11 and 17, we added records and pattern matching and sealed types and text blocks and local variable type inference and all of these goodies. And, so a lot of people are starting to think, oh, well, maybe I'll give a look to Java 17. But the difference between 17 and whatever the next LTS is going to be, I guess that's 23, is again going to be enormous because, between 11 and 17, we did a lot of features that were in the user's face, productivity features, like pattern matching, and those are great. And in between 17 and 23, you'll start to see these fundamental features that affect the runtime, the value types, better native interop, more scalable, asynchronous. So I think the goodies keep coming.
Yeah, I think there's a number of fields that at the moment Java is not used a whole lot, that Java will become extremely viable in with the low memory overhead of value types, with the scalability of Loom, with the easy interop with native solutions that Panama offers. There's really, Java is huge in terms of the amount of code that is written in it and the amount of use case that is viable for, but that will get larger, and there's a decent chance, that, for example, machine learning will happen much more often in Java. So actually, so another question that Tamas just asked, I think is very similar to this, what we just discussed. So he says, how do you see Java's future? Will Python, Scala, or Kotlin steal, in quotations, the Java developers in the near future? Or is there an ace up Java's sleeve to turn developers back from moving to these languages? Well, a couple of the aces I think we just already discussed. So how do you see that, like, in general, this development between, with different languages, some on the JVMs, some off the JVM?
Yeah, so I think like developers have this fantasy that somehow this competition is personal and nasty and dirty, that we hate Scala or we hate Kotlin. Like, nothing is farther from the truth, right? Programming languages are tools for people to solve problems. I want Java to be a tool that people find useful for solving a broad variety of problems, in a satisfying way. And the stewards for those other languages are all trying to do the same thing. And I think that's the rising tide that lifts all boats. The Kotlin developers and Java developers have a lot in common. The language designers, we have a lot in common too, and we read the same papers and we talk to each other at conferences, and we look at the experiments that have been done in other languages, for inspiration. And some of those, the inspiration is, don't do that. And sometimes the inspiration is, that was close, but we're going to twist it in this different way. And I think that competition is good. Competition makes things better. And so if you look at all of these languages, where they are now versus where they were 5, 10, 15 years ago, they've all gotten better. And that's winning for everybody. So I don't view it as we're trying to steal developers away from Scala as much as the people who find Scala pleasant to program in, we would like for them to also find Java pleasant to program in. And we're not going to succeed 100% at this, and that's fine. But if Scala was a fantastic experimental laboratory, right? In the early versions of Scala, they shoveled every feature you could imagine into the language. And some of them interacted in very surprising ways, which is what happens when you do that. And some of them turned out to be really useful, and some of them turned out to be not so useful. And we were able to learn from that, as a real world experiment. And for us, that's really important, because when we put something to Java, we're committing to it for several decades. So we don't want to do it we don't want to commit to something that we don't want to have around, right? I mean, the flip side of Java's commitment to compatibility, which, we try very hard not to break people's programs, and Java programs from 1995, for the most part, generally still run on today's JVMs. The flip side of our commitment to compatibility is don't do the things you don't want to be compatible with. All right. And so when we see experiments going on in other languages, that's great, because that gives us an opportunity to say, well, they did these 10 things and 9 of them, well, they didn't work out so great. But that one, that was awesome. Let's focus on that and pull that into the language. And if you look at, pattern matching is a really good example of this, right? So if you read Odersky's paper on pattern matching for objects, which is so that paper came out almost like the same month as Don Syme's paper on pattern matching in F#. But, this was a time at which everyone had assumed that pattern matching was purely a functional feature and didn't think pattern matching had anything to offer object-oriented programming. And here come 2 language designers of sort of like cutting edge languages at the time saying, hey, wait a second, pattern matching is useful for objects too. And if you're interested in pattern matching, go find Odersky's original paper, because it's really a nice little paper. So that really moved the ball forward, right? But looking at that paper, in the rearview mirror, now it's 10 plus years later, I was able to see that, well, they really didn't fully commit to pattern matching in the object model. They kind of brought pattern matching into the periphery of the object model, but all their patterns were static. And that is a totally reasonable thing for, like, they were doing something that had never been done before, right? But with 10 years hindsight, we can see, you know what? We could take that further. And so what Java is doing with pattern matching brings it into the object model in a much more central way than Scala did. Could we have gotten there without the experiment Scala went through? Probably not. We had to learn from their experience in order to be able to, see a better way to do it. So, it's kind of the Isaac Newton thing. If I see farther, it's because I stand on the shoulders of giants.
Yeah, I think the question was also a little bit pointed towards, there's a similar question also in the chat, in the Q&A section. Will like more people move away from Java and use other languages? And frankly, like I think it's now, that's actually part of my job now, is to change that impression that Java, not entirely without reason, got during a Java 6 and 7 phase, where really it did get. Like, it didn't move a whole lot, and there were a long time between releases. And it really felt like Java stagnated and nothing's gonna happen. Like, funny story, back then I was like programming at university every now and then I started a job. Like, Java 8 was the first release where I actually realized that Java has releases that change things. Like, I was not involved a whole lot. Of course, 6 and 7 did contain changes as well, but I was just so loosely connected to the language that I didn't even notice. I was like, oh, I can do this? Okay, I just didn't know. Like, I didn't notice really like that was like a big new thing. Lambdas was the first big new thing that I learned in Java. And I really think that if there ever was such a thing as developers leaving Java in huge masses, I'm not sure whether that actually ever happened, but like even if it did, and there were reasons for that back then, maybe, I think those reasons don't apply anymore. I think there are very few reasons to nowadays leave Java with this, specifically with the recent years and the next years that are coming. And so it's part of my job as well to convince people, look, if you think you need a vibrant language that innovates, that improves your everyday programming, that still has stellar performance, excellent tool support, all these other things we love about the JVM and about Java, then Java is a good place to be. And if somebody then says, like, well, I still like Python or Kotlin more, more power to them, that doesn't matter. But it's, but I think there's like an information deficit that I'm trying to fill. One more thing about what you said, that people are working together. There is the JVMLS, right? Maybe not everybody knows about that. The Java Virtual Machine Language Summit, where all the people working on JVM languages come together once a year, minus Corona, to meet and discuss exactly that, like shared solutions within the JVM that all the languages can benefit on, all of that.
Yeah, the JVMLS is really a cool thing. So we started that about 10, 11 years ago to basically bring together architects on languages for the JVM, tools for the JVM implementations themselves, to basically get together and compare notes. And, so we've had, language designers from all of the popular, JVM languages there, Rich Hickey and Martin Odersky and Andrei Breslov, and all of these people came to regularly to JVMLS because it was a place to talk to the the people who were doing the same thing you were. And for me, like there's an old saying. I think it was the Greek writer Nikos Kazantzakis said this: "Go take your paints and your brushes and your colors, paint paradise, and jump in." Right. And so it's like basically, imagine the world you want to live in and then go live in that world. And JVMLS was kind of like that. I imagined the conference that I wanted to go to. And we basically built that. And, it's a relatively small conference, maybe 100 people, but it is probably the most technically intense, conference I've ever been to. And it's very sad that we couldn't have it this year because of, the plague, but hopefully, we'll be able to resume that next summer.
Yeah. Okay, so I'm a bit afraid we're going to be cut off soon. So I just want to say that there's also, I think, afterwards, like more time for a Q&A session. So I'll definitely be around. I'm not sure about Brian. So, but you can still reach us even if you don't answer all the questions. Then you can always find Brian on Twitter and me as well. I'm DeepFX and you're just Brian Goetz, right, on Twitter as well. So you can hit us up there. No guarantee that we always answer all the things, but that's also a good chance to get in touch.
Yeah, I think we can continue. I mean, you can continue with the questions. So I think it's a good, as long as this is a good discussion, and I think it can keep going. Around 45, we have to cut it because then we will have to move to other sessions.
Okay, sure.
Okay, yeah,
so we have
7 more minutes.
Okay, so one thing that just to finish that topic about developers on Java and moving away. So one Balázs wrote a message that the problems of people leaving, but new developers not joining fast enough. Once again, sounds like I got my work cut out for me. We'll try to fix that. But he also had another question that was there for a long time now, so I want to get to that, and that's I can't exactly parse the grammar, but it's about AOT compilation that was removed in Java, but still GraalVM. It's still an interesting topic, I think, is what he's trying to ask. So the question is basically, what's up with GraalVM and AOT compilation in Java?
Yeah. So what was removed was an experimental implementation of AOT compilation that was it was experimental. It wasn't quite ready, for people to start using. It was based on the GraalVM technology, and the GraalVM technology is still available. That hasn't been, that hasn't gone away. And so I think people are sort of making more noise about this than necessarily they should. That they saw the JEP that says remove the experimental AOT compiler, and all that means is that this particular experiment didn't go where we were expecting it to go. And this is kind of like the story of AOT in a lot of ways, right? Over the last several decades, people have always questioned, well, why do your compilation dynamically? Why don't you AOT compile? Wouldn't that be more efficient? And the reality is that dynamic compilers produce better code. They take longer to get there because they have to do the compilation while the program's running. But in general, dynamic compilers have more information to work with. And if you have more information, you can make better decisions, right? So the dynamic compiler knows not just what architecture am I running on, but what exact version of the chip am I running on? Do I have AVX instructions, et cetera? And it also knows what your program is doing, right? So when a program loads at first, in the JVM, it gets interpreted. And interpretation is slow, but it doesn't interpret for very long because it keeps profiling counters that say, oh, I've invoked this method 1,000 times, I better compile it. And while it's interpreting, it also calculates profiling data on, have I ever seen null at this call site? What is the profile of types that I've seen at this virtual call site? And it uses that information to make better compilation decisions, which sometimes it can undo if it decides that it made the wrong decision. And so dynamic compilers produce better code, but they take longer to get to better code. Ahead of time compilation gets you very, very fast startup, but then not necessarily as good peak performance. So which is better? Well, it depends on your workload, right? There's not a one-size-fits-all solution. There are engineering trade-offs. And so if you have a program that's going to start up, do its thing, and shut down in 100 milliseconds, Well, you really don't want to be doing any dynamic compilation, right? You want to, statically compile that thing and have it load and go. If you're running, something like a WebLogic server that, is going to load 50 different web applications and run for 6 months without, then you don't care about startup, right? Because all of this dynamic compilation happens in the first couple of seconds, and thereafter it's still all native code. So it really depends what you're building, so in most of the cases that Java has historically been strong in, dynamic compilation has won, and so we've continued to improve our JIT and our dynamic compilation. But as you start to get into shorter running services, then maybe static compilation is a good candidate for those things, and we're going to get there.
It just might take some time, right? But Graal, I think at this, I don't want to make any announcements for them, but I'm pretty sure that they've already said that, but I'm not 100% sure whether it's correct. Just look it up with them, but I'm pretty sure that they also said that by fall, the next Graal release will also be Java 17 compatible, right? Because at the moment, I think it's pinned to 11, but they're working hard right now on doing 17. So you can just get the GraalVM and use all the fancy things you want to use, and just use that VM then.
Yeah, historically, they focused at first on 8 and 11, and now, they're sort of keeping up with the tip release, and so they have now, I think, experimental support for 16, and that will be GA fairly soon. And when 17 comes out, it will be some short number of months before they support it.
Yeah, that's a quick one. Marcel asks, Java concurrency in practice was released 15 years ago. And Brian, I think you can guess where this is going. Will there be a second edition?
Yes. So for a lot of years, it felt like, well, there hasn't been that much new to write about. So I didn't feel like it was too urgent to do anything. And then for a lot of years, I felt like, well, I could spend my time working on a new version of the book, or I could spend my time working on new versions of Java. And it felt like there was more leverage in working on new versions of Java. But, I think with Project Loom, that kind of changes the equation. That not only is Loom a huge addition to the toolbox, for concurrency in Java, but I think it's going to enable a host of new patterns that need to be explained and written about. So I am starting to think about doing not a second edition. A second edition is like this massive refactoring of an existing code base without the help of IDEs. So I don't want to do that. That would take years. So I'm probably going to do a volume 2. So the volume 2 would just cover what's been added since the first book, parallel streams and fork join framework, and virtual threads and things like that.
What about Ron? Has he expressed any interest in joining forces? Or does he know better?
One of the great things about Ron is he doesn't know better, and that's what allows him to charge ahead into uncharted territory without any fear.
That explains why he's so active on Reddit and Twitter too.
Yeah, he is unstoppable. I suspect there's going to be a lot of good discussions, with Ron. But yes, I am. People ask me that all the time. I would love for there to be a second volume. Maybe that'll happen soon.
Yeah. Further questions we have, let's see. One I can answer quickly on my own. I've seen a video that introduced records as stuff that helps you not to use Lombok, as you don't need getters and setters. Quit watching that video then, immediately. Records are not about that. Just like on a side note, and because the follow-up question is, do you have any plans for introducing something similar to classes as well? So I guess the answer is the resounding no.
Yeah, I mean, records are an interesting one because, as you say, people like to think that they are mostly about boilerplate because that's what they see, but they're actually about something, semantic, and the boilerplate is just a nice, side benefit of the semantics. But there are some, we do look at records and we say, okay, well, what features can we do for records? and then that come out for free, and then what would we have to do to bring those to classes, right? So pattern matching, deconstruction patterns is a really good example. We can derive a deconstruction pattern from a record without the user writing any code because of the semantic commitment the records make. But are those the only classes we would want to be able to deconstruct? Obviously not. So, we would like to make it possible that you could declare a deconstruction pattern in your class if it's not a record, and then be able to play along with that. And so we sort of view records as, there's, you get a lot of cool things for free out of records, and you'll get more cool things for free in the future. Some of those classes will have a way to participate in, some of them won't. But as you said, if you think about records as being mostly about getting rid of the boilerplate, you're probably on the wrong road.
Yeah. So hit me up elsewhere. I will give you a link to that blog post that I wrote that where I rant on for that for like, I don't know, way too many words. Yeah. Okay. So Benedict, how does that look? Is it about time or?
Yes, I think so. So thank you very much for this wonderful discussion and wonderful, answering questions. But I think it was a very good opportunity to actually talk to you in person. I hope you also enjoyed being at the conference, Nicolai and Brian. Yeah. It's cool.
Thank you very much.
Let me show you something. These are 2 mugs. I hope you can see it.
Oh, wow.
So this is supposed to be you, and actually this will be shipped to you. So it's a small gift from the conference. You will receive it. And thank you once again for those in the audience. Thank you once again for listening. Big applause for Brian and Nicolai.